No, that is the third set of desks back. So everyone that stood up and came, you are correct. Now, if you are in the front row, please sit on your desk. And if you're in the middle row, I'm going to give you the choice. You can come to the carpet or squeeze yourself in between and be on the desk. All right. So you guys can see?
Nope.
Adjust. Adjust yourselves if you can't see perfectly.
Yes.
You understand? If you absolutely need to get up, you're welcome to do so. There's space over here. Kendall, Evan, Nate, there's space over here if you need to. You all can see?
Yeah. Perfect.
All right. So let's pretend that this, I'm just going to put it in there. Linda, if I miss, you're my rebounder, okay? Yeah, let's pretend that this is there. By the way, in actual space, the sun actually does bend space like this. It's not visible, but this really does happen.
How though?
How? Because its gravitational mass is so great that it creates a curvature. In the 1950s, they struggled with the ability to correctly calculate Mercury's orbit simply because they didn't realize that Mercury was so close to the sun that it actually was in the curvature of the sun's bend. So let me show you how they did it. Let's put this right here. So let's pretend that this is the Apollo mission. It started right here, and what happened was this. Let's see, hopefully I can get this right. It's kind of tricky to get it. So they started right here, and they actually just pushed it along. I almost got it. Let's try another one.
Maybe push it harder?
Let's try a metal one. This one has a little bit more, what do we call it? Same size, but a little more weight. Mass. Just push it along. Oh, there it goes. That's pretty close to what it does right there. You see, we actually used the gravity, these two objects, just to manipulate where it should go.
Well, how does it go that way?
Why does it go good? You mean like that?
Yeah.
Well, it's following the path of the gravitational pull. So it goes down here, and then this thing is able to push down and grab it as well. So that's what the moon did. The moon has gravity too. You heard of the tides of the oceans?
Yeah.
That's the doing of the moon. The moon is doing that on Earth. So, let's see if I can do one more. Here we go. Oh. Should we try one more?
Yeah.
Okay. Let's try a light one. Let's see what a light one does.
Oh, my brother has that gun.
Yeah,
It probably won't go.
they got this toy.
Yeah, toy.
That didn't really work. Okay, so you guys got the message with that, right?
Yeah. Yes.
Now, let's talk about, you guys remember what nebula theory was?
Yeah.
With the creation of a solar system?
Yeah.
What is at the center of a solar system when it's created?
Stars.
A star, right? So we got a solar system, we got all the stuff in there, right?
Yeah.
Here's stuff. We'll wait for it to stop. Here's stuff.
Whoa.
Let's let it go. Watch what it does. Watch.
It collided.
Here, I'm not even going to throw it over there. I'm going to throw it over there. Here's stuff.
That's because of all of the mass.
It's about the gravitational pull.
Yeah. Well, what's that L word we use to describe that?
Leukemia.
I don't know why.
Yeah. Here's more stuff.
I don't know.
It's the
closer,
mass. So like, okay, so we can say that's Jupiter, and like, wait, so if you throw
Sure.
that in, it won't go to it because that one has
Now,
more
let's
mass.
change the gravity. Let's change it. Let's put a change in there. See what it does. I didn't change it enough, did I?
Nope.
Still even.
There's more.
One more.
Down.
Wait. Okay,
It's like Jupiter.
There it goes.
here we go. So, if I had all this in there, and I created now this giant singular mass pit here, what do we call that when we have a singular mass pit that's sucking everything in? Black hole. Watch this. even if I toss something this way,
It's gonna end up down.
Don't want to come back.
Whoa.
Gravity is pulling it.
yeah, gravity's gonna yank it either way.
What about a little
That
foam
one's
ball?
not gonna work.
Tristan, go ahead.
Yes, it will.
Try to make it go around. Go ahead.
Whoa.
Oh.
Oh, that one like.
That
So,
one's better.
if it didn't have the friction, because this thing has a little friction on it, he could have avoided what is called the event. What is the other one? Event.
Horizon.
You got it. You got it.
Horizon.
The event horizon. That's the point at which you can go orbit a black hole without getting sucked in, and actually successfully stay out of it. All right, let's pull it out. Please don't lean up against it when you pull it out. You just got to pull it out. There you go. There you go. Keep it coming. So anytime you see, let's go and put three of the big ones in there together.
Just put them in. The marbles?
Yep, just put them in. Don't worry, they'll find their way.
Just look at that. It's just.
There we go. So anytime you have something like this, and anytime it has enough, what is that V word? Movement.
Movement.
V word.
V.
Starts with a V, but it starts moving. What is it?
Velocity.
Anytime you have enough velocity, watch this. But now it runs out.
Oh, lighted.
These are, look at its mass.
That's very ball.
I can take it again,
Like
doesn't
moves.
matter where it goes.
So if you put it over there, it will go over there.
Do it. You do it. Why didn't it do that?
Because there's too much weight.
There's too much mass. Too much mass.
Try and catch.
What?
Catch. You ready? Do it.
That's
Okay.
great.
Roll it.
Oh. Oh.
You gotta go. What does that remind you of when it's going around like that?
It's like
Like a toilet.
True, but let's think about astronomy. What does it do in astronomy?
Revolving.
It's like, it's our orbits. It's the same thing. So the sun actually lets us go.
around.
Around it.
Well, and I'm not as good as you guys are, but you know, it's the same concept. I can see you're eager there. You want to try a few, huh? Go ahead.
Whoa.
All right, next we'll try another one.
It's like Jupiter.
Oop, there it goes.
Oh, missed.
Oh, that was.
Lillian? You have more?
Yeah.
Go ahead. We got time.
How'd you do that? He has
It goes.
voodoo magic.
Go. Try it in there.
Whoa.
So those are,
It's like biting.
try to make it go somewhere not here. Watch what happens.
Okay.
Here. Try to make it go.
It's orbiting.
There you go.
That's the best.
It's like a
That.
something.
But still with
Wow, Joe.
Beautiful, beautiful.
Oh, that's trying to make it go somewhere else?
Yeah, try to like make it towards Squirrel. Try to make it go towards Lillian a little bit. Thank you. Okay.
Oh, it likes you.
Watch what it does.
Whoa.
No matter what, it's gonna follow the pull of gravity.
Whoa, look at the.
that
the
orange
orange
one.
one. It's doing the same thing.
Orbit.
As it
It's
gets
orbiting.
closer to the larger gravity
Why
force,
did Jupiter do
you
that?
see how it accelerates?
It like that.
Goes like faster.
Jupiter
get
Jupiter did do
And
that
then
at one
Saturn
point.
got, and then just give
Then Saturn pulled Jupiter back into its orbit today.
Like a
Wait.
small black hole.
So I got 138. Here is the plan for the day. I'm gonna let you guys come up here and I'll call you up here in small groups. But you're gonna get a half a sheet today. And what I want you to do is I want you to start preparing to study for the test tomorrow, right? I know. Fast,
What is it
Jimmy,
about
fast.
Friday though?
Gotta do it. I know, I'm so mean. Gotta do it though, gotta do it. Anyway, prepare to study for it. You can be in study groups of 3. And I'll call you up here, I'll give you a few minutes to run this at a time. It's gonna be an open play as long as you are studying the concept of gravity. Do what you want, as long as you're studying gravity. Just be careful about leaning on this. This is PVC plastic, it's not that strong. So don't lean up on it when you grab things out. Okay?
Okay.
So as soon as you're in a group of 3, sit down. Stand until you're in a group of 3. Look.
Yay.
Go.